Okay, in the last class we have discussed different types. In the previous classes we have discussed the different types of circuits for whenever we are supposed to design an hydraulic and pneumatic circuit. So what are the different types of actuators? How the actuators is going to be considered? Those are all we have discussed. So in this from the previous classes, so now I'll go with respect to the next topic, that is the piezoelectric actuator. So before going into this actual consideration, actuators means it's a type of transducer which are of a precise or a ceramic object which is very much used to convert electrical energy into linear motion. So those generally we are going to consider as we are going to analyze it as a piezoelectric actuator. In case of this piezoelectric actuator, it is achieved with respect to the displacement, while indirectly or the directly of the deformation whenever a solid deformation is going to occur. Generally, it is having certain advantages with respect to the working condition. So that's generally we are going to discuss it by applying in most of the industrial applications or industrial equipment where precision control is to be taken care, like movement of the semiconductor exposure system, or generally the props which are going to be used in your CMM coordinate measuring machine or your STM machine, that is scanning internal microscopy, or AFM machine, that is atomic force microscopy. So these are the materials that are to be considered while designing any of the piezoelectric actuators. Here, the piezoelectric or the piezoelectric ceramic material which is used are generally made out of generates an electrical energy. So this is a simple basic thing with respect to any of the piezoelectric considerations has to be taken out. In case of this piezoelectric, as it states that it is a conversion between an electrical energy into mechanical energy, and also it's vice versa. So regarding the applications, it is going to be considered. So I think you're able to see the animated sketch, whatever which is going to be seen here. So that it itself states that whenever a power or a input voltage is going to be supplied to the material, so it gets vibrate. Piezo means it's vibration, so it gets vibrated. So that vibration will convert, and the initially electrical energy, that vibration will convert the electrical energy into your mechanical energy. So that is how a difference is going to be considered. In case of the piezoelectric, it is generally a ceramic actuator which converts electrical energy into a linear motion with maximum amount of speed, force, and unlimited resolution. Generally, these actuators are used in modern high life technology from a form with respect to your semiconductor test, so with respect to the microscopy, bio-nanotechnology, astronomy, aerospace. There, most of the time, they are going to use this piezoelectric actuator. A basic and simple example which I am going to give you as in your mobile vibration. It is done with the help of this piezoelectric. And one more thing, for pacemaker, for heart patients, the pacemaker, they are going to place it. So that is also is going to be done with the help of this piezoelectric material itself. Here, as you can see, the block diagram, it illustrates if if any electrical energy has to be converted to mechanical energy, then inverse piezoelectric effect, that is converting electrical energy to mechanical energy, whereas direct piezoelectric effect is converting mechanical energy into electrical energy. Here we are going to consider in the reverse form, that is from electrical to mechanical energy. So piezoelectric effect is same, but regarding the applications, we are going to decide whether we have to go for direct piezoelectric effect or indirect piezoelectric effect. That has to be considered. In case of piezoelectric effect, it is having certain features which are utilized for for solid transformation to derive any of the voltage. Like it is having higher accuracy. The accuracy with respect to any of the piezoelectric is having a high amount of accuracy. The response time is very much fast. The response is very much fast because, as you can see, in a fraction of seconds, in milliseconds or in nanoseconds, the voltage whatever we are going to get, it vibrates the material. So that vibration is suddenly absorbed by the device. So that's why the quick response, high keeping suspension. Suspension high keeping means generally here, especially in case of this, what you are going to observe is the suspension. Whenever the voltage gets induced to it, so there will be a cushioning of action will be considered. So that cushioning action will helps with respect to the suspensioning. So that's why regarding the considerations they are going to consider with respect to the high suspension, high keeping suspension. The next one is with respect to the low consumption. In case of this low consumption, the power consumption, whatever is going to be get, so that will be having a low amount. Low power consumption is going to be considered. That's why it is considered as low consumption. Then electromagnetic noises. What's the meaning of electromagnetic noise? Whenever a magnetic whenever a electric is going to be induced to a magnetic material, so then there will be an EMF is going to be generated or electromagnetic vibrations is going to be generated. So that noises has to be reduced. The noises also has to be get reduced. So that's why what they are going to do is with the help of this the electromagnetic noises whatever we are going to get that will be having a less noise or generally it's a noiseless condition will be available. Next is high density mounting in possible by small sizes. That means high density mounting in is possible by small sizes. Whatever the huge amount of vibrations that you require, it can be obtained by a small size of operation. So best example which I am going to consider is the same as your pacemaker. The pacemaker size is nowadays it is having a small size with respect to a small IC chip, but the size or the density whatever the mounting which we are going to get, so that mounting will be can high density mounting can be achieved with the help of this condition. So that's why high density mounting. And the last one is simple structure, it can be easily understood. So that is the basic things with respect to any of the piezoelectric consideration. Next, in case of piezoelectric actuator, it is a device that makes whatever the effect with respect to whether it is an inverse effect or a direct effect. So for example, just I am going to consider a voltage of about 1000 volt is applied to a piezoelectric ceramic plate which is having a thickness of 1 millimeter. Once you applied it, what's the final output electric field we are going to get? It is 1000 volts by volts per millimeter. So then a displacement of about 1 micrometer is obtained. A small displacement of 1 micrometer is going to be obtained, which is due to the inverse piezoelectric effect. However, in practice, because of the small displacement we cannot displacement we can obtain high drive voltage from lower state to higher state. So that's why what we are going to do is we are going to reduce the thickness. So that reducing of the thickness will yields you a minimum amount whatever the reduction drive voltage is going to be get. So best example is for the same example, if I am going to reduce, if we are going to reduce the thickness by 0.5 mm, then automatically the voltage drive will reduce us to 500 volts. So that's why regarding the applications we are going to consider what type of piezoelectric effect is going to be taken. So next, this is an example wherein the figure shows a different piezoelectric actuator. It is generally fabricated by processing two piezoelectric ceramic materials. So these are the two piezoelectric ceramic material. So with by fabricating these two, we are going to get the piezoelectric actuator. It is also called as bimorph piezoelectric actuator. Here, in case of this, it consists of the size with respect to the micrometer and the bonding between them with the help of a metallic plate. So in between that a small metallic plate is going to be placed and it will be considered. So this is here we are going to get two different input. One is a high input value and the strain gauge output. So these are the preloaded springs, the plate. These are the piezoelectric materials. These are the materials. So here we are having only two strips, but here it is a combination of one, two, three, four, five. So it's around six strips they are going to place one above the other. With respect to the high voltage, this piezoelectric material is going to vibrate. So that piezoelectric material, whenever it gets vibrate, so it absorbs and it will provide a strain gauge output. So this is one example where you can see the working condition. As you can see, the typical example with respect to the piezoelectric effects. So here, generally, sorry, generally it will be utilized with respect to the multi-layer or single layer. So that's the condition regarding the applications they are going to decide whether we have to go for single layer or multi-layer working conditions. Generally, a piezoelectric actuator converts, as already I said, it converts electrical signal into precise physical displacement. If the displacement is prevented, a usable force or a blocking force will get developed. So that blocking force is going to be utilized regarding the applications wherever is required. The precise movement controlled by the piezoelectric actuator is used finely for the adjustment of machining tools, lenses, mirrors, or any other equipments. Generally, the measuring equipments they'll go for, because in measuring conditions only we require high precise movement. So that's why regarding the measurement, especially the quality measurement techniques, there you are going to see this type of piezoelectric materials there, where we require a huge precise movement and also the fine adjustment, precise or fine adjustment where is required. So that's the condition regarding the piezoelectric actuator. A piezo actuator which is used to control hydraulic valves acts as a small volume pump or a special purpose motor, and in other applications which in requiring movement of force. That means with respect to the controlling of hydraulic valves, it works as a small volume pump and also a special purpose. There you require a precise movement operation. At that condition, they will consider this type of working operations. Next, in a piezo actuator, the piezo effect is of primary use. That means whenever whatever the vibration that we are going to get, that is a primary effect that we are going to use. The next is elementary piezoelectric materials which change the dimension when a force or a voltage is applied. That means a piezoelectric material changes its dimension when an additional force or a voltage is applied onto it. So that's why regarding the conditions we are supposed to decide what type of piezoelectric material has to be taken out and how the condition has to be obtained. So these two are to be considered with respect to any of the piezoelectric effects. And regarding the types of actuators with respect to the high useful application, here we can consider the precise positioning of mechanical devices with respect to the mirrors, which we are going to see in our satellites, the telescope, the non-magnetic miniature medical devices. So these are all the conditions has to be considered while designing any of the actuator. As I said, the non-magnetic miniature medical devices, like miniature medical devices, I had given a best example as your pacemaker. Nowadays, it will be used for your earphones, sorry, not earphones, hearing aid applications. Those are all the conditions where we are going to consider these operations, working operations of your piezoelectric material. So that plays an important thing while considering any of the piezoelectric materials. So the next is there are different types of piezoelectric actuators like stack actuator, and the one more is strip actuator. So first we'll discuss with respect, let us discuss with respect to stack actuator. Stack actuator is a device wherein the type of actuator for utilizing the piezoelectric, which offers low stroke and high blocking force. The stroke whatever we are going to get, that will be having lower amount of stroke and having a higher blocking force. with respect to the user requirement, the stack actuators can either be discrete or co-fired. So this is an example. Sorry, the sketch, whatever the picture, what you are going to observe, it's an example for a stack actuator. Here, it is of discrete. It is having a different parts or co-fired, a single part. So in case of the discrete stack, high voltage stack actuators are generally composite structures made by stacking different types of actuators and piezoelectric discs or rings and metal electrodes foil with the help of an additive, and these operating voltages with respect to these discrete stacks will range from 500 volts to 1000 volts or a minimum amount of operating voltages. So just imagine. Yes, Mano, who is this? So just imagine, as I say, as the name itself states that the discrete stacks, it's of high voltage stack. So there you can obtain a maximum amount of voltages. The ranging is minimum voltage. It ranges from 500 volts to 1000 volts typically. So this is a working application wherein the stack voltages is going to be taken out. So the next is co-fired or multi-layer structures, actuators. It is also called as monolithic stacks, where no adhesive will be there, but rather than it will be having high temperature sintering. Sintering means the joining. In the discrete, a adhesive will going to be adhere the ceramic discs or rings or metal electrodes. But in case of multi-layer, so a high voltage, so not the voltage, high temperature sintering is going to be taken out and complete for making the ceramic or the electrode pile. Pile means the huge storage one by one above the other. Generally, we are going to term it as pile. So regarding the operating voltages, it is having a mag co-fired. I have a voltage of with respect to the range of 200 volts. It is having a regular cross sections and which are typical due to the ease of cutting process in production. That means the whatever the cutting process that we are going to while obtained. So that cutting process is going to be used for the production condition. So generally, in case of the co-fired multi-stack actuators, it is generally a monolithic stacks, which involves no adhesive, but rather a high temperature sintering is going to be taken. The one more thing that has to be taken is both the discrete and the co-fired stacks, which can be insulated with the help of a coating material. So there is a coating material will be there. So that coating material is going to be considered with respect to the condition wherein we required a particular amount of operation. In case of a bare stack, it is encased in a stainless steel when protecting from the mechanical stresses and environmental extremes are needed. That means if it is of a open stack, if it is not an insulated stack, then generally what they are going to come across is they are going to protect it with the help of a stainless steel protection wherein it absorbs the mechanical stresses and also environmental extremities which is going to be avoid. So that's why regarding the conditions, this piezoelectric actuator is going to be used. Strip actuator. In case of this strip actuator, it is also manufactured with the help of a bending actuator. It is also, sorry, not manufactured, it is also termed as a bending actuator, which is designed to produce large mechanical deflections with respect to the response from the electrical signal. So this large mechanical deflections which we are going to obtain is going to be termed as your strip actuator. Here, the deflection offers large stroke and having very limited blocking forces. Whereas in case of stack actuator, there will be having a maximum amount of blocking forces. But in case of a strip actuator, the blocking forces will be having less voltage amount. So that's why regarding the condition, they are going to consider which one has to be taken care. In case of a strip actuator, it consists of two thin layers of piezoelectric ceramic which are bonded together, usually with the direction of polarization, which in turn consider the coercive forces or that which are generally placed with respect to in parallel condition. When any of the electrical input is going to be applied, one ceramic layer expands and the other contracts, causing the actuator to flex. So that is the actuator with respect to the strip actuator. So this, for example, so this is the sketch whatever you are going to see now. This is a strip actuator because here one gets expanding and the other one gets contracting. So here the passive conductive substrate is going to expand it and the piezoelectric ceramic is going to get contraction whenever the voltage is going to voltage source is going to be applied. So that's why regarding the applications they are going to decide whether we go for a stack actuator or a strip actuator. So next we will go with respect to the piezoelectric applications. Before going to this piezoelectric applications, generally these actuators or piezoelectric actuators are having high displacement accuracies, large maximum amount of force generated, high responses because of its lower drive voltage and also due to the reduction in the ceramic plates and also with respect to the plate thickness will be varied. If the voltage has to be varied, the plate thickness is also has to be gets varied. So that's why regarding the applications, they are going to decide what amount of plate thickness has to be taken care and how the piezoelectric operation is going to be taken out. So I'll just share another screen. Just a minute, I'll just show you one example where how the piezoelectric material is going to be used. So this is the best example for a piezoelectric wherein you are able to see the cantilever beam. In case of a cantilever beam, it is going to be fixed at one end. So there will be a voltage output. So this is the for x in the delta x in is the change in the height. So this is the tension. So this is the voltage. So this is the length width of the cantilever beam. The force in whenever the force is going to be get inputted. So here with respect to the layer, so there will be having two different layers. The one is the resistive, three layers. Above and below are the piezoelectric layer, and the middle one is the resistive layer. So that resistive layer is worked as an inner electrode, and the piezo ceramic layer are works as an outer electrode. So regarding the working applications, they are going to decide what type of voltage has to be given. The thickness is generally with respect to the maximum, it will be in form of micrometers. So that micrometer thickness cannot be easily seen, but it can be easily utilized with respect to the working conditions. So that is a simple example which I am going to consider here. Whenever the voltage is applied, there will be change in the thickness. That is what delta x in. So that input voltage gets varies the working operation. So that working operation is going to be considered, and the F in is the input force. So that input force will, but that input force will affect the cantilever position. So that cantilever position is going to be considered regarding the thickness T. So that if the thickness T gets more thicker, then the maximum amount of force is going to be applied. But also the input value is also has to be get increases. So that's why what generally they are going to consider is regarding the working conditions, they are going to decide whether we have to go for a minute thickness or a huge thickness working operations is going to be taken up. So the length and width, it will be with respect to the application. Let's take example in case of your hearing aid. So the length and width will be having a smaller values. There will not be any huge length or a bigger length because it will be in a minute form. Let's the one more example I am going to take with respect to your stress measuring instrument. There also they are going to use this piezoelectric actuator. There also regarding the applications, if it is of a huge size of a truck weighing measurement instruments, then they'll go for a little bit bigger size. If it is of a smaller household equipment weighing equipments, then they'll go for a smaller amount of working conditions. So that's why regarding the applications, they are going to decide what amount of size and how and which type or which shape, whether it is a strip actuator or whether it is a stack actuator. So those are all is going to be considered and it will be utilized regarding the applications. Regarding the piezoelectric actuator, it is a voltage. There will be the form of voltage, whatever the form voltage that we are going to consider, that voltage is going to be taken out. Yes, ಹೇಳಪ್ಪ ಯಾರು ನಾಗರಾಜ ಏನು ಹೇಳು ನಾನು ಏನಾದ್ರು ಡಿಸ್ಕಸ್ ಮಾಡಕ್ಕಾಗತ್ತೆ ನಿಮ್ಗಳ ಹತ್ರ ಅನ್ನೋದಕ್ಕೆ ನಾನು ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ಬಿಟ್ರೆ ನೀನ್ ಗಂಟೆಗೊಂದ್ಸತಿ ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಂತ ಕೂತ್ಕೊಂಡ್ರೆ ಏನ್ ಮಾಡೋಣ ಹೇಳಪ್ಪ. ನಾನು ಅದನ್ನು ಡಿಸೇಬಲ್ ಮಾಡ್ಬೇಕಾಗಿತ್ತು ಅಷ್ಟೇ. ಏನಾರ ಕೇಳಕ್ಕಾಗುತ್ತೆ ಅನ್ನೋದಕ್ಕಾಗಿಂತ ನಾನು ಮಾಡಿದ್ರೆ ನೀವ್ ಈ ಕೆಲಸ ಮಾಡಿದ್ರೆ ನಾವ್ ಏನಪ್ಪ ಮಾಡೋಣ. So that in case of piezoelectric actuators, generally it is utilized regarding the applications where it has to be taken care, how it has to be considered. So generally we are going to term that as piezo sensor applications, piezo accelerometer, piezoelectric generators, piezo actuators. So that are the applications wherein this piezo plays an important role with respect to the working operations. In case of this piezo, the piezo working condition, it is also called as piezo theory. In case of this piezo theory, it accumulates the charge with respect to the piezoelectric effect, and piezo materials, which are in turn includes different types of crystals, and which will also generates the working operation. So till the end of the meeting, I'll just continuing the class. Once it get disconnected, I'll again restart the meeting. You all just reconnect it. I'll just continuing the class with respect to the working of the piezoelectric. So in case of this piezo, it is a type of material wherein it generates piezoelectric effects. It includes different crystal, ceramic, which also generates the voltages with respect to the responses, which is applied to the mechanical stresses. It is what is known as inverse piezoelectric effect. Sometimes, regarding the applications we are going to consider, some of the piezoelectric ceramics that we are going to consider are there will be having a certain lead zirconate titrate material, which are generally used regarding the applications wherein they are going to consider certain piezoelectric materials which are going to be considered are as follows. I'll just inform you. So some of the piezoelectric materials that are going to be considered, starting from your cane sugar. A best and simple example is your cane sugar, barlanite, or it is identical to your quartz, rochelle salt, topaz, tourmaline, and bone. So which most of the piezoelectric effect material is going to be done with respect to the working condition. Generally, these piezoelectric materials can classified with respect to the crystalline, ceramic, or polymeric. So this polymeric is going to be manufactured. Ceramic is initially obtained, like your quartz or your certain other rock salts. Those are all in obtaining. And whereas one more crystalline, that crystalline form with respect to your cane sugar, the salt, whatever we are going to consider, those are all is going to be considered. In case of ceramic, like as I said, lead zirconate titanate or barium titanate and lead titanate. So regarding the considerations, they are going to consider what piezoelectric material has to be considered and how it has to be utilized. So one more best example I can give you for your piezoelectric application is your cigarette lighter, what we are going to see. So it is also a piezoelectric material wherein we are going to see a piezoelectric effect. With the help of the piezoelectric effect, the spark is going to generate it, and the button, when we are going to press it, it sends the gas out of the nozzle and it starts burning. So that is a simple example where we are going to see, as I said, piezoelectric crystals like quartz, barlanite, topaz. So in case of quartz, the second most mineral available in the earth, barlanite, a rare transparent high temperature mineral, topaz, a gemstone that forms numerous color, and the next cane sugar, which is manufactured to your granulated sugar. Rochelle is not made from first materials found. That is like potassium, sodium tartrate, and monopotassium phosphate. So these are the considerations. As I said, with respect to the ceramics, barium tartrate, lead tartrate, lithium niobate, lithium tantalite, potassium niobate, sodium tagnate. So these are the conditions. Like one more thing has to be considered is hard and soft piezoelectric material. So regarding the hard materials, wait a minute. I will continue in the next session. That is, in a while the session is going to come end. So I'll just end up now itself, and again I'll ask all of you to rejoin it. I'll just start the same.